Hi, everyone. Thank you so much for joining us on this session today. I'm here to introduce our next speaker, Vin Vashishta. He started his career off 25 years ago installing servers and networks. Now he installs strategies that monetize machine learning models. Vin has spent the last 8 years helping people break into machine learning and push this field forward. His technical expertise is in custom model development for pricing and natural language understanding. Please welcome our next speaker.
Hi, I'm Vin. I'm here today to talk to you about the realities of machine learning, basically as impacts based on COVID. And where I want to start is with my sort of derivation of a quote by von Clausewitz. And he was talking about war, and I'm talking about disruption, and a lot to do with each other. Resistance will continue until the pain of resistance is greater than the pain of accepting disruption. And we've all looked at the machine learning field at one point or another and said, why aren't businesses doing more with machine learning? Why hasn't the data science profession become more organized? Why hasn't it become more standardized? Why is a lot of the sort of obvious moves forward that we would expect from any field not happened here as much as it should have? We've got a lot of hype. And really the answer is this quote. It is that resistance will continue. Resistance against adopting machine learning continues until the pain of continuing inertia exceeds the pain of accepting that disruption and changing. COVID is the event. COVID is that sort of event that creates the pain which will move us as a field and businesses towards serious adoption. And that's the impact that I want to talk about today. And I'm going to talk about it from two perspectives. One of them is if you're in the field or trying to get into the field, I want to walk you through exactly what this time means to you. What does it mean to your career? And how can you stay relevant and stay in front of a lot of the changes that are coming as a result of COVID? And if you're on the business side, this is the moment where you've probably started to realize a lot of businesses aren't going to survive this. And it's not necessarily for the reasons that everyone has sort of brought forward that are obvious. There's some very not obvious reasons why businesses won't survive this. And one of them is very central to machine learning and a few of the machine learning business cases that I'm going to get into very, very soon. And I know the requirement for a meme slide is, it's perpetual. So here's my meme slide. And there are right now two theories of the economy. The top one talking about the V-shaped recovery and recovery of employment. Obviously, I'm a proponent for the second theory. If you look at workforce participation, it is at a 25-year low, and it has not been this low in a very, very long time. And that's going to be one of the important things that I'm going to come back to as a driver for what's next in data science and machine learning. The next is obviously the stock market's recovering, and we have to look at the dollar. We have to look at how much money is being pumped into the economy. And I know the economy seems like a weird place for me to start this talk, but these are the driving factors which are going to, from a career standpoint and from a business standpoint, impact sort of the why COVID is the event. Why is this going to change things so much? And it is because COVID has created this confluence of events where money is cheap, money is freely available, companies are going to be incentivized to invest, and the way that the unemployment picture is shaping up, we are going to look at our field sort of taking not so much an unemployment impact, but an impact based on the way that hiring and value from our field is going to change. And so, like I said, economics seems like a dry place for me to start, but you have to understand these governing forces, sort of these undercurrents, in order to understand what's coming next. And our field is, I want to say this with respect to a lot of fields that have lost jobs, our field's fortunate, and we should really take a moment and be thankful that the data science field has been as resilient and the machine learning field has been as resilient as it has been. Your drivers of demand are returning. If you look at the way that recruiter search has happening right now, it has recovered to essentially where it was in February of this year, and that's huge. That's a huge recovery. And if you look at other IT fields, and I'm going to talk about this near the end, they have not recovered as well. They have not recovered as quickly. They are doing better now, but they have taken some hits that the data science and machine learning field have not. Our drivers, company drivers of demand remain strong. You've got sort of the segmentation between your traditional bread and butter data scientists and your more forward-looking research arm, the machine learning scientists, deep learning data scientists. We'll talk about this in the next slide. We're in a field where job titles don't really mean anything. So when I say this, just realize I'm using these as buckets, and we'll talk about more of the meat and potatoes of what they really mean later. Your data scientist is the highest demand, and that's important. It's amazing, again, that we have recovered as much as we have, and that there are still so few people who are applying for all of these open data science positions. Your highest growth is machine learning engineer. This is a hot job title, and I'm sure we've all heard of it, but I want to talk more concretely about what a machine learning engineer is, because it's one of sort of these three pillars of value that I'm going to get into. And that's what's driving a whole lot of this growth in the machine learning engineer. And your highest salary is your deep learning data scientist, your machine learning scientist. Again, goes by a lot of names, but those are your highest salary positions. And there are so few people available that there are companies that just have a standing job opening, several standing job openings that never close. And the companies that are out there, almost all of them have something that's been open for 3 months or more than that. There's simply still more demand than there is supply in the machine learning and data science field, which is excellent for us. And there are still going to be impacts, even though this seems like a very, very rosy picture. There will still be impacts. And again, I just coming back quickly to the recruiter search focus. Where recruiters search for data scientists, machine learning engineers, you can sort of see that the generic searching and recruiting, it's coming back. So if you are coming into the field right now, it's still a good time. You haven't missed the boat. There's no, there is no sudden drying up of positions. You'll be fine. And so again, with respect to the other fields which are not faring as well, ours is doing very, very well. Now, if you thought you were going to get through this without some sort of model, you were wrong. What you're looking on the left-hand side, I'm going to explain in deeper depth, but at the 50,000 foot level, job titles don't mean anything in data science. Data analyst, data scientist, machine learning engineer, machine learning scientist, none of those words have any meaning. They were made up and they were best guesses. We have to label our field as something, and these are sort of the umbrella labels that I've chosen, but I don't want you to think that I am really in love with any of these job titles or that these job titles are standardized somehow. Again, the words are meaningless there. But what I want you to focus on is sort of where did these numbers come from? This is an evaluation of how practitioners, people in the field who are doing jobs, describe themselves, how they describe the way that they add value to a project, how do they build. It's a reflection of how businesses explain what skills, what capabilities go into creating a successful project and building value for the business. And so this is a bit of an aggregation of a number of different views of the different positions in our field. And what you see here from a career standpoint is sort of the blueprint. If you're coming into the field, or if you're in the field right now and you're looking for the what's next, how do I stay current, this is the blueprint. If you are a business who really wants to get into machine learning, is in machine learning and needs to go a little bit deeper, wants some clarity on what everyone in the field does, again, this is the blueprint. And what we have now is going to be changed a lot by COVID, because we have these two bookends, which I'm calling data analyst and machine learning scientist. And the bookends are very well defined, but what's in between is not. And so when you talk about all of these ridiculous job titles and job descriptions that are, a half a mile long and ask for everything in the kitchen sink, really that's these two in the middle, the data scientist and the machine learning engineer position. So those are the kitchen sink positions. You see down there in red, stop trying to be everything to everyone. And that's what COVID is going to change. COVID is creating a tangible need for value. And that's something I'm going to get into very deeply in the next slide. But that's the driver. That's why COVID is important with respect to how we as a field not only define ourselves, but how we decide what skills are important for a particular role, and how do all these roles fit together, because they do interlink to create three pillars of value. And again, I'm going to get to that in just a second, but I want to go through each one of these roles in a little bit of depth. You look at your data analyst role and the value that a data analyst creates, and you kind of see that reflected in the numbers that are most associated with the capabilities that create value for a data analyst. This is very business facing. This is very data facing, very business facing. And so this is the closest connection that the business has to its data. And there's a lot of value that a data analyst can add. And very frequently, there's significant overlap between data scientists and data analysts, to the point where the two job titles in a lot of cases are very blurred. And that's again where I say segmentation is going to start coming into this. And at the other end, you've got the machine learning scientist. And again, their role is very, very well defined. They have more of a high-end technical skill set when it comes to producing custom models, whereas a data scientist is specifically saying, I do research, and the companies say they do research in order to make us money. The machine learning scientist sort of bucket is more specific to a use case: bioinformatics, computer vision, natural language processing. There are also some autonomous in there. And so it goes from a very broad, I do research, to a very narrow, here is my area of expertise. And so again, you see some of the more advanced frameworks also reflected in the machine learning scientist. And then you see the data scientist, and you see all of these sort of scattered capabilities. Again, back to everything to everyone. The value of a data scientist from sort of the three pillars, and again, I promise I'll get to three pillars. I keep mentioning it. I'll be specific about it in a second. But kind of in that three pillars of value, they are more of a model, more advanced model creation, while still having a lot of the business facing parts of their role that a data analyst would have. And so you have technical skills to support that. And it's a bit of an advance from a data analyst. The data analyst has a lot of the same technical skills, but for a data scientist, they have progressed towards the model development direction. A machine learning engineer, again, you can see that they're sort of the everything to everyone, but when it comes to what value that niche is going to start really adding to a business, what value our business is going to start demanding from a machine learning engineer, you're looking at the machine learning engineer being the connection between the model and production. And so if we segment the field in this way, and I think COVID is going to force us to do that, because businesses are now demanding value from their data science teams and their machine learning teams, it forces segmentation so that each one of these roles really becomes a clear component of value. And your three pillars of value, your first one is very represented by the data analyst, and that is the ability to create data-driven services for the business. And again, that's back to that very business-facing, the very high strategy business acumen role. And the data scientist is sort of the next step in that role, and it provides similar value. It allows for more complex models to be created in a business-facing capacity, but also now you switch to the second pillar of value. And the second pillar of value is being able to do more automation and more new feature additions. And this is sort of an intangible piece of distinction between products, but you have products that are driven by new and incremental features. And that's really what data scientists look at, is new incremental features, and they're also able to provide automation, which is a cost savings to the business. Now, the machine learning engineer fits to be able to take what the data scientist has created and get it into production, to monetize it, to productize it, to make it real. And that's where the machine learning engineer creates value. And finally, your machine learning scientist is, again, that sort of stratification in products. They create new products. They are able to sort of do the advanced R&D side of the field. And so why is all this important? It's important from a career standpoint to understand sort of how do you get in? And once you're in, what do you do? What skills do you focus on? If you are trying to get in, your data analyst role is really your entry point into the field if you're already sort of in work now. If you're in academia, a research assistant's role is completely valid. It is almost a universal translator in our field. It comes in to play in each one of these four buckets, and you can move into them from sort of an academic role. So busting that myth that you can't get hired straight out of college, you can, trust me. And a data analyst has high mobility into a data science job by simply transitioning their skills more closely to the model development and improving some of the technical skills to support that. Your machine learning engineer, again, you can come into it from a research analyst position or a position in academia, but you can also, it's sort of the mobility into the field for software developers, software engineers, more of your technical type of skill set. And so if you're looking to get into the field and you are in software development, software engineering, machine learning engineer is a great entry point. And the machine learning scientist is really where you come from data science, from the data scientist position, and it's sort of your next step. But so is machine learning engineer, and those two are becoming machine learning scientist, machine learning engineer, two of the most valuable positions to businesses as they try to productize. Now, what's driving productization? And that's, I'm coming back to economics, and I apologize, but this is your career, this is your business. If you don't understand sort of the undercurrents of what's going on, it's going to be very, very hard for you to have a successful career or for your business really to survive. And so let me explain two concepts, transient and static competitive business models. Your transient competitive business model, and the reason why you need to understand which one of these two you're in or you're going into is because from a career standpoint, if you want to go on the sort of machine learning scientist career path, you're looking for a transient competitive business model. And the transient competitive business model, back to that earlier slide, is really companies like Apple, Microsoft, Amazon. Those types of companies are able to build new technologies and monetize those technologies. So they have the advanced R&D use cases, which a machine learning scientist can actually contribute to. Remember, they have the specific niche skill sets like natural language processing, computer vision, bioinformatics, and so on, that allow them to create those new products, novel products, which is a bit beyond just being able to add new features or do some automation for the business. And so if you're going in that path, you have to identify a transient competitive business model. And if you look at a company like Microsoft or Apple, they've actually gone through several iterations. They started out being able to monetize new technology, and then they kind of both turned into static competitive business models where they looked and felt like every other company. And then Microsoft has recently made the transition back to a transient competitive business model. Apple made the transition back to transient, and now they're back to static, and I think they're trying to get back to transient. So no one company is stuck. No one company will remain the same type of business model for its entire lifespan. But it's important, if you want to go that track to the machine learning scientist, that you focus your career on a transient competitive business model, because this is a very small number of companies. This is a very small minority. The vast and overwhelming majority are static competitive business models. The reason why that's important to know is if you are going the data scientist or machine learning engineering path, the static competitive business model companies are going to be heavily looking for you because they need automation now. They need cost savings now. And the reason for that is because as July 1, I've got that in red on there. And the reason for it is July 1, beginning of the new fiscal year, we are going to see some dramatic changes in business as they begin to plan for next year, as they begin to sort of anticipate the disruptions of COVID. You're going to see their budgets change. You're going to see the focus on value change because margin is going to become very, very hard to come by. And so you're going to need, as a company, to create as much value out of every sale as possible for a business. And that's going to mean a heavy reliance on automation. And automation is one of our top business cases across the board for data science and machine learning. And again, back to that, the pain of resistance has to become greater than the pain of adoption. COVID is that event. Now, the pain of losing margin, the pain of losing sort of part of that sale is going to be greater than the pain of changing and adopting machine learning, which will drive automation. And so that competition on price, which is where static competitive business models always end up when things get tough, requires automation. And you're going to see that really drive, again, that segmentation. Because now that a business has to get value from our field, now that it has to get value from its data science and machine learning teams, this suddenly becomes a focus for upper level management. This suddenly becomes something that will be under greater scrutiny. And that's when you see these sorts of standardizations and changes come into any technology field. And so we are going to see companies who look at, again, back to free money, back to a lot of the economic factors, they are going to have money at their disposal to invest, and they're going to see automation and machine learning as a long-term investment. And it's going to be something that returns significant value for them. And so now that there is this sort of pressure to produce for these companies, you're going to see them start demanding different types of talent, start getting really serious about segmenting what each role in the organization does to create products. And again, back to those three pillars of value. You have the business facing, the data analysts who are business facing, creating data products for the business to consume. You are looking at the data scientists and the machine learning engineers who are facing sort of that second pillar, which is feature enhancements for existing products and automation for cost savings. And then you finally look down at the machine learning scientists. And there's going to be a hard expectation for them in transient competitive business models to produce new products and to use some of the leading edge research that we have and productize it. And so again, from a career standpoint, that has obvious ramifications. If you're in the business strategy side of the world, now is the time that you need to, number one, identify which one of these two business models you fit into. Most fit into static, and that's not going to change in the next 6 months. And then understand what that means from a project and from a skill standpoint. And in a lot of cases, again, I talked about mobility. This talent's in the company right now, and with some basic reskilling, it can be very quickly sort of created instead of having to be hired externally. And so this is a strategy time. This is there's a lot to cover in a very short amount of time. Let's just put it that way. And from those two directions of the business and the field, they're working now to come together because of COVID and because they have to create something that's more structured and something that's more value directed. Now, we are very much aware of impacts now of machine learning. We talk a lot about impact statements. And so what I want to end with is, this is sort of grim, and I don't mean it to be because it's an opportunity. But everything we automate, every time we put a product that automates a job into production, That's a person. In this case, it's going to be tens of millions of people. And so look at the bottom first. We can talk about the actual numbers in a minute. Machine learning is going to make all of the job losses you are seeing now permanent. And when I say all, I am not being hyperbolic. As companies, again, compete on price, as COVID creates this sort of demand for margin, competition based on price, again, that's the business case for automation. It is the business case for our field, which is great for us. But it is not so great for the people who are not going to be coming back to work. And in the 80s and 90s, when we saw that first sort of inkling of automation getting into manufacturing, the implications of that we're still seeing today. There were people making great middle class livings, working at the same company for 35, 40 years, and having a great career, and that was taken away. There were a lot of people mid-career in those manufacturing jobs who lost their jobs and couldn't get the same salaries back when they went back into the workforce. And we are seeing that again. But we have an opportunity this time. We're in front of it. We have time as a field to sort of look at two directions. One's policy. Obviously, I don't make policy, so I'm not going to try to go into that direction. But the other one's education. Every time we create anything in the machine learning field that is going to automate jobs out of existence, we need to see the people behind that, and we need to bring awareness to the fact that this particular product that we're building is going to have impacts on people and their jobs and their careers and their ability to feed their families and themselves. And if we don't at least bring that up, if we don't at least bring that to the front, and we don't at the same time talk about what jobs are going to be more in demand, we are going to continue to have sort of this struggle of how do we keep people employed? How do we keep people in the workforce? Because again, back to that workforce participation number, it's dropping, and that drop doesn't come back. As we saw in 2008, that drop does not come back very easily. And so we have to look at the impacts to white collar, middle class workers, hospital workers, IT, within our own industry, and people who are really without the means to move into a field, or don't have a lot of access to a field which is growing. And we need to talk about what sort of an education safety net can we put in place? Are there things machine learning can do? And I believe there are, but again, I'm not going to go down the policy road. But I think that every time we build one of these automated solutions, we need to at least advertise what the impacts are. And that's what I want to leave you with today. So with that, let me take some questions.
Okay. So we have a couple questions in the chat. The first one is, what would you suggest a data analyst student graduating recently, 2021? What would you think his new journey into the job market would be like, and career aspects, specifically in the Canadian job market?
If you're looking at Canada, Canada is actually a lot like the U.S. And I don't understand why a lot of people make a distinction. They'll say, well, no, the Canadian market, no, it's the same. The use cases are very, very similar between the U.S. and Canadian job markets. So if you're looking at sort of what your career path will be, look again back at the slides, and your data analyst bread and butter role is very, very business focused. You want to look at your ability to be a good data analyst, do the analytics. The visualization especially is huge. The ability to communicate, to manage projects, to interface with other organizations and with customers, that's very important. But you also want to be looking forward. Well, how do I get from data analyst to either data scientist or machine learning engineer or machine learning scientist? While you're learning now, you also want to be learning with a direction. And that's what I wanted to sort of give in that third slide was, this is what you're learning towards, and also pick your companies.
Okay. Our next question is, So is the role data scientist the 2020 version of predictive modelers in the past for people with statistical background?
Uh, I guess I go back to where I said job titles are meaningless, and that's the that's so data scientist. It depends what you're talking about. It is as vague as predictive modeler, and so if that's really where you were going with it, yeah, data scientist is the air quotes predictive modeler. But if you look at what value the bucket that I was talking about with data scientists can create, what you really want to emphasize is those more advanced modeling capabilities. And it's hard to think of regression and clustering and all of those what we call basic, but those are the ones that produce a lot of business value. And so data scientists having those mathematical, statistical sort of tools in their toolkit, and then the technical skills behind them, Python, R, pick your data wrangling skill set of choice, and sort of your frameworks as well. But keep it very, very directed towards those with the business acumen still there to back you up. And I think that's what a data scientist will be over the next 2 to 3 years.
I see. Okay.
And I look at the wait, what clients? Yeah, so David and I talked about this talk a while ago, and the wait, what clients are the ones who I will say something to, and they'll have a moment, and I get a couple of reactions from clients, but a lot of times when I explain what's coming and how machine learning should be used and how the field could actually create value, I get the, wait, what? And it's really because they haven't seen sort of the reality of the field. They've seen a whole lot of sales pitches. They've seen nothing wrong with sales pitches. If people didn't spend money, I wouldn't have a job. So all respect to sales and marketing. But the wait, what? Clients are the ones who hear what could be done. The ones who hear that there's a completely different model of value, and that what they're doing is analytics with the name machine learning slapped on it. With what's going to happen in the next 5 years to my business? Well, you haven't adopted machine learning, you're already done. You're out of business. I'm sorry, I can't help you. And I say that a lot, and that's the wait, what moment for a lot of clients. There's some small ones where I say this could be better, this could be better, this is how you should really do it. And then there are other ones where I say, I'm sorry, you're probably going out of business because you're too late. And that's a really big wait, what moment to realize that the bullet which ends the business, which puts the business under, it's already been fired.
I see. That's a great answer. So the next question is, what would you tell a trucking union with respect to automation of long-haul transportation? So fields that can get automated.
If you're a trucker right now, and this is something that I've been talking about for 2 years, so it's a really good question. Education. Stop negotiating for salary, start negotiating for education. And that isn't just money for education. Right now, we're throwing money at problems and saying, good luck, you figure it out. And that's not what I mean when I say education. What I mean is time on the job that you're getting paid for to reskill. And I don't mean now I'm going to be a back of house person. I mean reskill entirely. Your career is going to change entirely over the next 5 years. So if you are in your late 20s, early 30s, even into your 40s, you could, in the next 5 years, not have a job. And nothing skill-wise that you have right now, no capability that you have right now translates well into another job that will be in demand. And so education, demand, training, retraining, reskilling, and don't just get a paycheck for, here's some money for education. Have companies create programs to move employees from where they are now out of fields that are going to be automated and into fields within those companies which have more long-term security and stability.
Let's see. So the next question, and just for the sake of time, are you okay with fielding more questions right now?
Oh yeah,
okay.
It's pretty much the end of the day for me. So
okay, that's awesome. Then so one of the questions asked, how do you prevent the data science and machine learning IT community from being politically toxic in this sense?
That's a good question, because I have wandered in and out of sort of making some statements, and I've never really gotten political, but I have covered issues.
Mm-hmm.
And I think the best way that we can as a field sort of keep ourselves involved while not taking, that there's sort of this limit once you're involved and you can advocate, and that's great.
Mm-hmm.
But you take that next step, and that's where things get sort of riskier. I don't think anyone would disagree with giving people equal rights. I don't think anyone's going to look at that and say, no, that shouldn't happen. I have a hard time with that. And so there's advocacy. There's no way to disagree with that position, unless, you're obviously an evil person, which I don't think any of us are. But then we go to the next step, and suddenly there's a political label that you can place on things, and that's where we get toxic. And I think we have to draw the line and say, look, everyone has the right to their own political beliefs. But when it comes to people beliefs, when it comes to anything that impacts how someone makes a living, how someone sort of feels safe, secure, access to education and opportunities, all of those things are sacred. You can't say that we shouldn't give education access. You can't say that we're not going to keep everyone safe. You can't. That's the line. You can't say that. It's simply not true. And I don't think anyone. I guess raise your hand if you think there's a group of people that don't deserve the same rights that I do. No one's going to raise their hand. And again, once you go past that, that's where I think a lot of us get into trouble. And from sort of the standpoint of there's always trolls, which is true, and a lot of them are fake. That's our problem, is we have a whole lot of voices that aren't real people. They are propaganda. And I think we have to basically say, if we find this, we're done. You're gone. That's it. That sort of trolling will not be tolerated. But at the same time, we have to allow a path back in, because people change. The whole point of all of what's going on right now isn't everyone who's done something in the past is terrible. The point is, we should be better, and we all have to be better, and that's only possible if there's a path back in once you've made a misstep.
That's really insightful. There's quite a few questions. So the next question is, so in terms of, I guess, following the previous question, how do you have any sense on how machine learning and data science is evolving in public sectors, and then compare that with the private sector?
It's a really good question. Public sector, it's very, very limited. It's so heavily scrutinized. When you talk about anything public facing, policy facing especially, I've worked in policy a couple of times, and it's everything scrutinized, everything. And I think that level of rigor is actually very healthy when it comes to most of what we do. But then on the other side, there's sort of this balance of innovation, and that's your private sector. There's a race to go far and get there quickly. And so there's balancing act. So when you talk about public versus private, where are we going in machine learning? We're going to sort of see the two meet each other someplace, because I watched John Oliver last night. I'm not plugging anyone. I'm sorry, I shouldn't have said that. But I was watching a show on HBO where he talked about sort of the implications of facial recognition.
Mm-hmm.
And within our field, we've been talking about that for, what's it been, 5 years, 6 years now? And it's now just getting picked up by the policy side.
Mm-hmm.
And so we have to, as innovators, inform the policy side, hey, this is what you should be watching out for. Mm-hmm. I've been telling friends for over 5 years, do not put pictures of your small children online. Mm-hmm. Don't do that. You know, think very, very carefully about what you put up online because it's there forever. And so we should be informing sort of the non-technical and policy world. And the policy world also needs to, and a lot of this kind of comes back to my last slide when I talked about public impact and sort of the impacts of automation. People have to say, hey, we're here. This is happening to us. We need your attention and we need you to fix this. Mm-hmm. We need to be able to quickly respond to that. We need to be able to shift our focus there because that's very, very, very important as far as not only accountability and responsibility. These are new company ideas. Mm-hmm. Protecting people's privacy online. I have no idea why we haven't seen that startup yet. Mm-hmm. Why haven't we seen the one that basically says, I will look at every, Facebook had the drunk text or drunk post avoidance a while back, where it was a joke going around. They're going to advise you, you've drunk posted. Are you sure you want to post this? And we sort of need that for privacy, where it just pops up and says, you don't want to do that. In 5 years, you will regret this. Don't do that. Mm-hmm. And it's sort of those types of things that the policy side of the world can kind of bring back and say, why don't you build us products like this?
I see. So I guess this kind of, would you say the private sector, for example, what's going on with, you mentioned face recognition or image mm-hmm. recognition, a lot of the larger tech companies are actually advocating for going back and looking at their business policy with that technology. So I would, in my head, I would see the private sector also has a role in driving, informing policymakers.
Yeah, the way I look at it is this. I mean, the companies like Amazon, Google, Facebook, IBM's doing it. I know there's more than that, but those are the ones off the top of my head. Going back and looking at Microsoft, them too. Going back and looking at facial recognition technology and saying, we should reevaluate this. That's like hitting somebody with a baseball bat and then saying, I need to look at this baseball bat. I think maybe it's time to look at the baseball. Mm-hmm. No, you already hit him. It's done. Mm-hmm. That one's out. You can't look at this and say, well, because there's 30 companies out there who aren't. Mm-hmm. The technology was created. The technology was open sourced. The data sets were put out there in the open. Companies built products based on them. This is no longer a genie that's just in the bottle for three companies, sort of like nuclear weapons. Mm-hmm. It started out in a couple of countries' hands, and it's all over the place. Same thing. You can't do that now. You have to look at the next thing. Mm-hmm. This is sort of a battle that we have to fight differently. It isn't the tech companies, it's really, again, policy. Mm-hmm. But at the same time, we have to be looking at the next battle. There are still things out there that are far scarier that we do have control over. Mm-hmm. When it comes to privacy, when it comes to monitoring. There's a lot of really scary things out there. And those are the dragons that the big companies should be chasing, are the ones that are 3 to 5 years down the road, mm-hmm. not the ones that are, like I said, they're already out of the bottle. Why? You can't stop facial recognition. It's already mm-hmm. out there. Police departments can hire 2 or 3 different people. The NSA, not going to go there, never mind. But there are organizations who already have done this themselves. They don't need to, they're not waiting for Google to call. Mm-hmm. So we need to focus our attentions as larger tech companies on more forward-looking threats and inform, again, the policy sector that these threats exist now, and there needs to be sort of a, can you clean up my mess approach? Mm-hmm. And we're sorry, we won't make another mess again.
Mm-hmm. I see. And another question in terms of, I guess this is jumping further back. And you mentioned that education is very crucial, and specifically, how would you approach recommending how to skill up, how companies would, what sort of skills would you recommend?
So skills is the wrong word. I
Mhm.
spent a lot of my career using that word, and it's still applicable. I mean, you can call Python a skill, you can call scikit-learn a skill, pandas a skill. You can do that. It's not invalid, but reskilling is a different concept. And so when it comes to education, what should people be focused on? The most important thing to be focused on is value. And the most important means to education is training. It isn't looking at, sending people to college, then bringing them back and hoping for the best. You have people in your organizations right now who are experts. Reskill them to be trainers and educators. And if you look at, I wrote a post on employee lifetime value modeling, which is sort of this emerging thing that looks at the whole, it kind of kills the traditional biases of the employee sort of career and comes up with it's 3 cycles. You have an education, an application, and then a training. And so you learn, and that is best done by having a mentor in the company teach you. And then you going and doing what that mentor is teaching you to do under some pretty good supervision of some people that are very, not only experts, but very good mentors. Then you apply what you've learned, and then as you become an expert yourself, you become a mentor. And again, you are reskilled. And so if you want to look at the paradigm, that's sort of the cycle in a nutshell. And everything kind of changes there. You don't have a learn Python anymore. It's not generic because you have projects. The company has specific projects to do. And you can now say, well, Python's great, but for this one, we actually need a little Java too, or we need C or C++. Maybe we need Scala. And then you see a lot of the use cases for things like R and other languages. R and Scala are really good examples where some companies have an extremely strong business case to use those. And so now reskilling becomes something different because now it's company specific. And now you're bringing somebody who's already in the company and then skilling them specifically for the projects you have over the next 2 to 3 years. And instead of saying, now I've got this job description that's looking for 50 people and I don't know what I'm really looking for, and hand waving, now you have sort of this internal initiative that takes people, invests in them, and then gets them invested in the business. Because your skills are so specific to the business that you're in, it's easier to stay. And your skills are so valuable to those projects that it behoves you obviously to stay. You're going to get well rewarded for it. This is the cycle. And so when you look at reskilling as a career, you want to look for companies that are doing this. Not talking about sending you to boot camp, not talking about sending you to get a master's or a PhD, not talking about sort of this amorphous, I'm going to train you, go over there and figure it out yourself. But if you're looking for companies to get into, look at the ones who have this sort of learn, apply, mentor. Learn, apply, mentor. That's the cycle that's going to set you up for long-term success. And those are the companies that are going to survive the next 15, 20 years.
I see. Okay. And I guess the next question.
Looks like Vivek, David just pointed out.
Oh, yeah.
Some of my clients are small and okay, public sector. What are some of the low-hanging cases for machine learning in the public sector? That's a broad question, but it's a really good question. I think I go back to automation and look at what parts of your business are the most expensive when it comes to time consuming, looking at labor costs. There are a lot of things that employees do every day that they hate, absolutely hate doing. And these are especially cases where gathering large amounts of knowledge from distributed sources is critical to improving outcomes. You look at a lot of medical use cases there, but this is across the board. Any sort of public sector company, you can see use cases where knowledge work, which is drudgery, not processing work, not thinking work, but just going out and finding all of the information that the person needs to do to accomplish a particular task is labor intensive. If you can automate those, using machine learning to automate those, again, computer vision and natural language processing, perfect, absolutely perfect, sort of broad niches, broad skill sets that have wide applications when it comes to automating the drudgery. That's the low-hanging fruit, because you'll find everyone's an expert in how it gets done. So training those systems is very, very easy. And there are thousands and thousands of examples out there that you can train from because this task's been done for years. And like I said, just the lowest hanging fruit is typically go into an office, listen to people complain, and then fix that. Use machine learning to make their complaints go away, because normally their complaints are the things that take them the most time and they don't feel produce any value.
I see. So I guess this would be more of a personal question on how, like, day to day. I definitely agree with you about the point of basically automating what everyone hates doing. I'm personally struggling between the point of taking what I'm doing, which is very script based. I basically build various like macros for people to sort and organize the data. How do I've always wanted to move towards machine learning. How do I find use cases in those where I found like it's more convenient to just do scripting? Do I need to look for a bigger problem, or is it just
No. Small problems. Very small problems. The interesting thing about small problems is that they are onions. And you fix the first problem and then you find out that wasn't really the problem. And so what you're doing right now is perfect. You are being given sort of these pieces of problems, and right now you're using very basic quick win type of mechanisms. Am I right?
Yes.
And so what you're finding is that those solutions are inadequate. You are finding sort of the next layer to the problem, and you're iterating quickly. That's how you get into machine learning, because at some point you're going to find a problem that's big enough that, number one, there's a lot of ROI behind solving it. And number two, it's complex enough that you're going to need some sort of algorithmic approach. And so the easiest way to move from where you are right now into machine learning is, obviously you have to pick a tech stack and pick the one that works best for you and for the company that you're with right now. A lot of people make the mistake of, I'm going to go with Python because everyone else does. I'm going to go with R because everyone else does. No, go with whatever you want to. I build models in Java. You can do it in anything. So pick the tech stack that makes the most sense for you. And I think there was a question in here about learning a cloud platform. Docker, Amazon, Docker. That's, if I were going to recommend one, Docker's amazing. It saved me years of my life. So it's those types of tech stacks, where you can hear I have an obvious preference, and it's because it works for me. And so, learn your tech stack that works best for you, and then start applying it to those problems. Don't start using machine learning on small problems. Don't do it. That's the biggest mistake that you can make, and it's one I've made it. Everyone's made it, I think, in their field, is you bring, a machine gun and you need a scalpel. And so just use the right tool. Do not bring a deep learning algorithm to a knife fight. I've said that before. Don't do it. It's not worth it. So you're actually doing machine learning better than a lot of companies are doing machine learning. Solve the small problems. When you find a bigger problem, figure out what the best way to solve it is. And those projects are going to be your gateway into the field. Also find a good mentor. Find someone who can help you sort of apply the scalpel correctly. You don't want to be, no patient wants to see that.
I see. And I guess that kind of links to another question that we have in the chat, which is, what's a good way to showcase a visionary idea proposal for prototype? So if I found that bigger problem, and there is a way to solve it by doing the way things have been done, which
Mhm,
is basically very small, precise band-aid, I would say band-aid solutions. But
mhm.
how would you bring, I guess, senior leadership into pitching them that idea of going that direction?
Don't pitch them.
Mhm,
Let them come to you. Best way to pitch a machine learning solution is to let it sell itself.
mhm,
The companies will not invest money unless it hurts. And it's back to my first slide. Until the pain of adoption becomes lower than the pain of resistance,
mhm,
nothing changes. And so when we talk about pitching ideas to senior leadership, let them come to you with the problem, because that's where they're saying, I have pain. And in
mhm,
a lot of cases, data science teams we know what we can do. And we look out there and we say, do you have any idea what we could do here or what we could do there or what we could, and we see all of these different places where we can add value. And we need to listen to the business,
mhm,
because what they will say is, this is the most important thing that we need.
mhm,
And we have to trust them. If you don't work for a company that you trust, don't, leave. You
mhm,
have to trust them to come to you with the types of problems that are most valuable to the business to
mhm,
solve. But you can also give them tools that may help them see a little bit better what's wrong with the business. And that's a lot of the setup for pitching your idea.
mhm,
Is if the pain isn't seen, if it's not visible, your data analysts are worth their weight in gold here, because they can reveal the problem. They can create a tool that showcases exactly how much is being lost.
mhm,
And as a data scientist, you want to run and solve problems. And a lot of times, solving problems is a process of revealing the pain,
mhm,
allowing smart people to make good decisions, and then come back to you and say, I do want you to fix this. What can you do? And then you have that sort of solution in your back pocket, almost like NASA, when they finally get the green light for an ambitious project. They've been working 5 years on a solution, so one just comes flying out. But it really takes the problem coming to them in some cases, and that's true with us a lot.
mhm. I see. Okay, well, that's very helpful in my day-to-day career. And I hope that I also answered some of the everyone else's question. I think
Looks like we got one more down there. What can you do when you're stepping into a company that has some serious technical debt, legacy technology? Yes, walk in with a forklift, and they never want to see the forklift. I've had to tell companies that machine learning is going to cost a whole lot more than they want it to. And this kind of goes back to the wait, what? It Nobody wants to hear this, and I say this a lot. I say no to clients a lot, and the reason is because there are some companies that are so, I don't know, married is the wrong word, but handcuffed is probably the right word. So handcuffed to legacy systems, and their teams are so sort of handcuffed and stuck in maintaining those legacy systems that there's almost no way for them to move forward. And so there are some pits that you can't dig yourself out of. And that's unfortunately the truth. I wish I could say, yes, I can fix everything. I can't. The company has to first commit to, number one, the budget it's going to take. And there's going to be a big budget. It's not going to be a small thing. It's cultural change. As I said, with the legacy, especially with the legacy systems, it's a cultural change. And they have to understand that machine learning introduces its own sort of concept of technical debt, which means you have to maintain the systems you've created. And in a lot of cases, companies don't realize their machine learning systems are legacy systems. It's another one of those, wait, what? Clients is when I say that you have a machine learning sort of infrastructure in place that's legacy. Sorry, you can't move forward because of it. You need to forklift it out. And that's one of those terrible moments for a client. But it's the reality of what needs to happen in order for a company to move forward. And so addressing legacy and technical debt is really a matter of, number one, buy-in and budget, and then number two, sort of that long road of transitioning out of all of this sort of baggage. And companies about halfway through this process realize, wait, this is way cheaper than that was.
Mm-hmm.
And so the ROI, you can put it on a slide, and this is again why you need buy-in from the top on that budget, because it isn't until you get about a year into the project that everyone in the company really starts to feel, oh, this is better.
Okay, I think that should be most of all the questions. This was an amazing presentation, very informative, and I thank you so much for staying to answer all these questions. And
thank you for having me.
So,
all right, I'm gonna sign off. If you do have any questions, you've got my LinkedIn down there. I'm gonna nope, that's the easiest way to reach me is on LinkedIn. Go ahead and feel free to send me a message there. I usually respond at least fairly quickly, and I look forward to some conversations in the future.
Definitely. Thank you.
All right, thanks. Bye.